Good morning, students. In this tutorial, I'm going to show you how to run an independent sample t-test for significant testing using a dichotomous independent variable and a continuous dependent variable. So here's SPSS. This is our survey, variable view, data view, same old, same old. What you're going to do is you want to compare a dichotomous variable, let's say gender, and a continuous variable. We could use liberalism, expected income in 10 years, etc., etc. You're going to go to Analyze, Compare Means, and then go to Independent Samples t-test. The test variable is your continuous variable, so we can use age and all these scale numbers, but let's try expected income. The grouping variable is your dichotomous variable. It is worth noting that you are using two variables, hence the term dichotomous. You can also use two variables out of any of our nominal continuous variables. So, for example, you have party affiliation where you choose strong Democrat, weak Democrat, strong Republican, weak Republican. You could pick two of those, but you're limited to only two when you're using an independent samples t-test. So here we choose gender, and then we plop it into the grouping variable. You'll notice that it'll come up with two question marks. It is asking for you to define your groups. If you remember, back in the variable view, you would define your groups using numbers. In this example, 1 for male, 2 for female. You'll do the exact same thing. 1 for male, 2 for female. The reason why you have this option is if you were to choose some nominal variables, where you have, say, strong Democrat, weak Democrat, strong Republican, weak Republican, those are 4. So you wanted to compare strong Democrats and strong Republicans, you would choose 1 and 3 if they were labeled as such in the variable view. Click OK. And then it'll give you some group statistics. Here is the number N of men in this class who took this survey, 8, and women, 13. The mean for expected income in 10 years for men was $93,750, with a standard deviation of $50,000. For women, it was 78 with a standard deviation of 26,000. From looking at this alone, it seems like men have a higher average, but they're more greatly dispersed. That's why the standard deviation is higher, with 50 compared to 26. So how do we know that there is a significant effect on expected income due to gender? Well, here you have the independent samples test. And with this, you can find out exactly if this is significant. Remember, in this course, we are using a significant or p-value of 0.05, meaning that the null hypothesis is rejected 95% of the time, or at least 95% of the time. You'll have two different rows here. Equal variance is assumed and equal variance is not assumed. In order to complete this, you will look at the significant value. If your significant value is above 0.05, then you will stay with this row, equal variance is assumed. If it's below 0.05, as it is in this case, you will go down one level to equal variances not assumed. You will notice that we are given our degrees of freedom. Now, degrees of freedom are indicated by the n, or the number of observations, minus 2. And this t is our t critical. Without even using the SPSS significance over here, which is what we will be looking at ultimately, we can figure out if our t value, t calculated, is higher than t critical. If t calculated is higher than t critical, that means it is significant. If it is not higher, it doesn't meet the threshold. It is not significant. Here we have 19 degrees of freedom. If we were to stay up here, we move down, but we'll look at 19. And at 19 degrees of freedom, using the alpha level of a two-tailed test at 0.05, this is Appendix C, page 326 in your Berman and Wang book. At 19, the threshold is 2.093. We can see here that the t-value, the t calculated, does not exceed 2.093. We already know that it's not significant. We could do the same thing with equal variances not assumed because we were lower than 0.05, so we go down here. 0.787 with 9 degrees of freedom. At 9 degrees of freedom, it needs to exceed 2.262. Clearly, 0.787 is lower than that, so there is not a significant relationship between gender and expected income in 10 years. However, if we wanted to use SPSS, as we should, because it is a wonderful tool, we would look at the significance to tail. Significance is the p-value, and we always want it to be less than 0.05, meaning we are rejecting the null hypothesis 95% of the time. Unfortunately, the significance here is 0.37 if we did equal variances assumed, and 0.451 if we do equal variances not assumed, which is what we'll be using because significance is lower than 0.05. So we move down a row. 0.45 is greater than 0.05. Therefore, we now know that the relationship between gender and expected income in 10 years is not significant.